Hello students, welcome to Trunkie Academy. I am Dr. Pallavi Kulkarni, your chemistry teacher, and today we are going to learn about the next topic from chapter acid, bases and salt, and that is nothing but the salts. Okay. Before discussing for salts, let us just have a quick recap of previous session. So we are going to discuss the topic from the chapter acids, bases and salts. In the last class, we have discussed about the importance of pH, in everyday life. In which we have discussed the importance of pH in first about acid drain, pH of acid drain is lesser than 5.6. Then second we have discussed about pH of stomach juice. Then third one is pH in tooth decay. And then fourth one we have discussed about the pH in leaves or some other things of animals, right? For example, pH is present in acids are present in some animals like ant bite has the formic acid. So yes, that part we have discussed. So self defense in animals and plants. Okay, so first we have discussed about in that stinging hair, of nettle leaf, second bee sting, and third ant bite. Okay, these chemicals which are released in their attacks contains acids. Okay, for example methanoic acid, also called as formic acid. Okay, and therefore ants are also called as, ants are called as formica. Formica stands for ant. Therefore this acid, methanoic acid, is commonly called as formic acid because it is present in ant. Okay, ant bite. Okay, so this was the importance of pH in day-to-day life, which we have discussed in the yesterday's class. Then today, apart from that, we are going to discuss some examples of acids in everyday substances also. Before that, you just take a screenshot of this page and then we will discuss about the next part. Okay, now let us see some examples of acids which are which we found in substances in everyday life. Very popular example, thus all the citrus fruits contain the citric acid, tamarind contains tartaric acid, etc., etc., right? Milk, the curd contains lactic acid. So these are some examples that you should know. You should know their names, and you should know their origin, from the source from which they in which they are present. So that's why I'll give you the list of such a substances, such a acids, okay, which are present in day to day life. Just give me a second, I'll draw the table for that. Okay, so this table contains the, yes, we are going to discuss naturally occurring acids. Naturally occurring acids. Okay, then natural source from which it is obtained. Natural source and acid. Okay, let us see examples one by one. So if it is vinegar, as we know, vinegar is nothing but 12 to 15% solution of acetic acid. In Greek language, acetum, acetum, acetum stands for vinegar. Therefore the acid present in vinegar is also called as acetic acid. Okay, then next example or next substance is orange. As I have told you, in all citrus fruit the acid present is citric acid. Acid present is citric acid. Then next is tamarind. I have told you, in tamarind tartaric acid is present. T for tamarind, T for tartaric. You can remember it like this. T for tamarind, T for tartaric. Tamarind contains tartaric acid. Tomato contains oxalic acid. Then curd contains lactic acid. The name of the sugar present in the milk is lactose. Therefore acid present in curd is lactic acid, because curd is obtained from milk. Then lemon is also a citrus fruit only, so it also contains the same acid present in orange, that is citric acid. Then next is ant sting. I have told you, it is nothing but the formic acid, or formic acid is also called as methanoic acid, which is also called as formic acid. Methanoic acid is also called as formic acid, FORMIC, methanoic acid or formic acid. Okay, similarly in nettle sting also the same acid is present. Right? The name of this acid is methanoic acid, which is also, methanoic is the name, IUPAC name. Formic acid is the common name. Right? Okay, so these are some of the examples of substances which are naturally occurring acids. Right? Just take a screenshot of this page first of all, and then we will discuss the next part from this chapter. Okay, take a screenshot of this page fast. Okay, now after this we are going to discuss the next part from this chapter, and that is nothing but about the salts. Okay, let us start this about the salt. Okay, as we have discussed, when we are performing the reaction in between acids, acid react with a base and it gives you the salt and water. Acid react with a base and it gives you salt plus water, right? Okay, so as we know, acids are acidic in nature, bases are basic in nature. So the salt obtained from that depends on the nature of that salt, depends on the nature of the acid and nature of the base used in the reaction. Okay, so first of all, we are going to discuss about the family of salts. Okay, we are going to discuss first of all about the family of salts. Okay, what is the meaning of family? So family is nothing but it gives you the idea about the nature of the, or what you can say, the name of the ion which is present in the particular salt, right? For an example, I'll give you the examples. Okay, so if it is the potassium sulfate, some examples I will write down on the board. If it is potassium sulfate, the formula for potassium sulfate is K2SO4. Okay, then next is the sodium sulfate. Formula for sodium sulfate is Na2SO4. Then calcium sulfate. Formula for calcium sulfate is CaSO4. Then copper sulfate. Formula for copper sulfate is CuSO4. Then magnesium sulfate. So many examples you can add here. Magnesium sulfate, aluminum sulfate, etc., etc. The formula for magnesium sulfate is MgSO4. Okay, now what do you find, what is the common in between all these examples? All of them contain sulfate, right? All of them contain sulfate in it, right? All of them contain sulfate, right? That is the common thing present in all of them, right? All of them contain sulfate. The formula for sulfate group is SO4. The formula for sulfate group is SO4, right? All of them contain sulfate group, SO4 group. So that is the common part in all of them, right? Therefore, if you want to classify them into one family, right? Therefore, if you want to classify them into one family, that will be called as a sulfate family, right? That will be called as a sulfate family or family of sulfate salts, right? Family of sulfate salts. Do you understand that? That will be called as the sulfate family or family of sulfate salts, right? Okay, so I'll write it down. So this is called as a family of sulfate salts. Family of sulfate salts, right? This is the family of sulfate salt. Their sulfate ion is an anion, right? So anion is common in them. Therefore, this is the family of sulfate salt. Let us see few more examples. So if it is sodium chloride, okay, formula of sodium chloride is NaCl. Then next example, sodium sulfate. Formula for sodium sulfate is Na2SO4. The next example, sodium carbonate. formula is Na2CO3. Next example, sodium bromide, formula is NaBr. Sodium bicarbonate, or which is also called as sodium hydrogen carbonate. Formula is NaHCO3, right? Okay, so in all these examples, if you can see, sodium is common, right? In all these examples, if you can see, sodium is common, right? Sodium is the common word in all of them. Therefore, this is the salt, or this is the family of sodium salt. Sodium ion is a cation here, right? So I will call this family as family of sodium salts, right? This will be called as family of sodium salts. Do you understand? So you have to simply find out which is the common thing present in this formula, then you will call it as the family of that particular ion. If Cl is common, family of chloride ion. If SO4 is common, family of sulfate ion. If Br is common, family of bromide ion, and so on, right? Okay, take a screenshot of this page now. Okay, yes, so I hope you have taken a screenshot. After the family of salt, next concept we are going to discuss for salt, and that is nothing but the pH of salts. Okay, and that is nothing but the pH of salts. Okay, first of all, let us see the classification of salt on the basis of its pH. Salts are of three types. First type is called as acidic salts. Second is called as neutral salt. Neutral salts. And third type is called as basic salts. So these are the three types of the salts. So in them, the pH of acidic salt is lesser than 7, pH of neutral salts is exactly equal to 7, and pH of basic salts is greater than 7. Okay, yeah, so these are the different types of the salts on the basis of their pH. Let us see one by one. So first of all, let us see acidic salts. Okay, let us see acidic salts. How the acidic salts are formed? Very easy. Let me just give you one simple trick first of all to find out the nature of the salts. It's very easy. So what is the trick? So if you know, yes, just let me use some abbreviations first of all. So strong acid is nothing but SA. Strong base is nothing but SB. Weak acid is nothing but WA, and weak base is nothing but WB. Okay, so these are the symbols which I am going to use to explain this. concept. Okay, so if you start with strong acid, if you react it with the strong base, right? Here both of them are the strong. That means both of them are going to cancel out each other's effect very completely. So here we will get a salt plus water. Like here we will get a salt plus water. That salt will be a neutral salt. Okay, that salt will be a neutral salt because both of them effects of both the acids and base, they are cancelled out because the both of them are the salt strong in nature, right? The next, if you start with strong acid only, but if you treat it with the weak base, right? So here acid is strong, but what about the base? It is weak. So here whatever salt we are getting, here also we'll get salt and water. Here salt which we are getting is acidic salt, right? Because acid is stronger and its effect is still there persistent because the base cannot nullify the effect of acid, strong acid, because the base is weaker. Okay, and then if you start with the weak acid and strong base. Okay, here base is stronger, acid is weaker. Here also we will get the two parts, that is salt and water. Just the here base will be salt will be basic in nature. Why this is so? Because it is base is stronger in this reaction. Okay, and the last one, if you are using weak acid plus weak base. Okay, now in this case there will be no reaction, right? Because out of these two, any one should be stronger in nature. If the weak base, both of them are weaker, then we will not get any salt formation. No reaction will take place, right? So this is how you can just find out the pH of the salt on the basis of what type of acid or what type of base you are using. Okay, so first of all take a screenshot of this part, and then we will see the next concepts on the same topic. Take a screenshot. And the types of the salt on the basis of the what type of acid or what type of base you are using. So list of some salts I am giving here, so out of which you have to find out which one of them are acidic and which one of them are basic. Okay, so I will give you the list first of all. So the list is sodium chloride, okay, formula is NaCl. Then next example is potassium nitrate. Potassium nitrate formula is KNO3. Then next example is zinc sulfate. Formula is ZnSO4. The next example is copper sulfate. Formula is CuSO4. The next example is ammonium chloride. Formula is NH4Cl. The next is sodium acetate. Formula is CH3 COO Na. So these are the examples out of which you have to tell which one of them are acidic, which one of them are basic. Let us start with the sodium chloride. NaCl is the formula. So NaCl will be formed by using the reaction of NaOH and HCl, right? NaOH and HCl, NaOH is a strong base, HCl is a strong acid. So when we are treating strong base with the strong acid, we are getting NaCl and water, right? So combination of strong base and strong acid will result into neutral salt, right? So NaCl is a neutral salt, right? NaCl is a neutral salt because it is the combination of strong base and strong acid. Next example, potassium nitrate. So potassium nitrate will be formed by the reaction of KOH plus nitrate, that is HNO3. Okay, HNO3 is the nitric acid. We have seen about this acid in the yesterday's class. So KOH is also a strong base and HNO3 is also a strong acid. So here we are getting KNO3 plus water. So KNO3 is a salt of strong base, strong acid. Therefore it is a neutral salt. Right, it is a neutral salt. Okay, then next example is zinc sulfate. Zinc sulfate is formed from ZnOH twice, zinc hydroxide plus H2SO4. Okay, sulfate comes from H2SO4. So here we will get ZnSO4 plus H2O, right? So zinc sulfate is a weak base. Zinc sulfate is a weak base. H2SO4 is a strong acid. Therefore we are getting here, just a minute, H2SO4 is a strong acid. Therefore we are getting here acidic salt. Strong acid, acidic salt, right? Strong acid, acidic salt. The next example, copper sulfate. It is obtained also from CuOH twice, copper hydroxide plus H2SO4. Here also we are getting CuSO4 and water. CuOH twice is a weak base, H2SO4 is a strong acid. Therefore what type of salt we are getting? Acidic salt, right? We are getting acidic salt here in case of copper also. Okay, then next, ammonium chloride. So ammonium chloride is obtained by the reaction of NH3 plus HCl. Okay, and we are getting NH4Cl, ammonium chloride. So NH3 is a weak base, HCl is a strong acid. Therefore we are getting acidic salt, right? Okay, then last example, sodium acetate. Sodium acetate is formed by NaOH and acetic acid. Formula for acetic acid is CH3COOH. Okay, so here we are getting the salt CH3 COO Na plus H2O. Okay, so here we are getting this salt from strong base and CH3COH, acetic acid is the, I'll write down its name here, acetic acid. This is acetic acid. It contains carbon in it, therefore it is an organic acid. Okay, organic acids, and all organic acids are, with few exceptions, organic acids are weak acids. Okay, all organic acids with few exceptions, they are weak acids. So combination of weak acid, strong base, we will get a basic salt. right? We will get a basic salt. Okay, so this is how from the nature of acid and base combining we can find out the nature of the salt produced, right? It is very easy. Just take a screenshot of this page now. These are the examples for the salts. Take a screenshot, everyone. Okay, yes, so I hope you have taken a screenshot, and that's all about the pH of the salts. In the next class we are going to discuss about some examples of the salts which are useful as far as industrial as well as pharmaceutical use. Okay, so that's all for today, guys. I'll just show you before ending the class. I'll just show you the daily practice problem for you, DPP. So I hope you are able to see this page. This is a teachers portal. Similarly, there will be student portal in which you have to go to resources, then to writing material, and you will be able to see DPP over here, daily practice problem. You can download this DPP. You will see the questions here in DPP. You will solve those questions on your notebook. Take a picture of this notebook and just submit it. So in the action I'll be able to see if you have, after you submit the assignment here. Okay, so that's all for today, students, and in the next class we are going to discuss about the salts in detail. Okay, or examples of salt we are going to discuss in the next class. Okay, thank you so much, students, and thank you so much for your precious time, and all the best to you. Bye bye, take care.